Ashok sir or Shalu ma'am, anyone, any,
Yes, sir.
you may continue. You may continue.
Right, sir. Shalu ma'am, please go ahead.
Okay, sir. So good afternoon to one and all. I'm extremely overwhelmed to get this opportunity to introduce our speaker of this session, Dr. Partha Pratim Roy. He is an associate professor in Department of Computer Science and IT at IIT Roorkee. Sir has done his BTech in Computer Science and Engineering from University of Kalyani, MS and PhD in Computer Science and Engineering from Autonomous University of Barcelona, Spain. Sir is working on pattern recognition, multilingual text recognition, biometrics, computer vision, image segmentation, biosignal analysis, EEG based pattern analysis, machine learning, deep learning, and temporal data analysis. He is an associate editor in EICE Transaction in Information System, IIT Biometrics, IIT Image Processing, and Springer Nature Computer Science. He is also regional editor of the Journal of Multimedia and Information System, Journal of Defense Acquisition and Technology. Sir is a member of various professional bodies, that is IEEE, Institute of Document Analysis and Knowledge Science, Japan, Research Advisory Board of Patanjali Research Foundation Trust, Haridwar. Sir has also organized various conferences in the capacity of coordinator. Dr. Roy has visited various institutes in South Korea, Japan, Greece, and Kolkata for collaboration and as a visiting scientist to share his work experience. Sir has published 127 journal articles in IEEE, ACM, Springer, and 98 conference articles. So on behalf of the organization team, Bhadava Campus, University of Jammu, and Ramanujan College, Delhi, I welcome sir in the today's session and extend my best wishes to you. Now I request Dr. Partha Pratim Rai to kindly take over the session and share your valuable experience with the participant. Sir, please.
Yes, thank you, Dr. Shalu. Thank you very much for this nice introduction. So I would like to thank also Professor Ashok Sharma and Professor Jatinder Minhas for inviting me in this FDP event. So thank you very much. I have already visited this Vaderwa campus. It's a nice campus. I am associated with this campus for a long time. So yeah, it's a nice campus. Thank you very much for inviting me in this event. Yeah, it's unfortunate this time I am not there in this campus, but yeah, we are having this lectures in online event. Yeah. So anyway, so today my lecture will be on this machine learning using this scikit-learn. Okay, so I would like to share my screen. Yes. Is it visible, madam?
Yes, sir, it is visible, sir.
Yes, thank you very much. Thank you. So, during this lecture, you may send your comments or doubts, whatever you have, in the chat box. And if there is something, then I will try my best to resolve those clarifications. You may contact me anytime in this my email address, and I'll be happy if you contact me and we can have some interactions. So my email address is mentioned in the footer, partho@cs.iit.ac.in, right? And you may find the details of my publications, projects, and team experience in this parimol.iit.ac.in. So Parimol is the name of my team. Okay, so this is a short form of pattern recognition, image processing, and machine learning. So my students are working in this different areas of machine learning and pattern recognitions. So today the plan is to discuss a tool, okay, so on scikit-learn, how we can use this on machine learning. So as you know, this machine learning, machine learning is a buzzword in these days, and everyone is talking about this machine learning, data science, this cloud computing. Okay, so this machine learning, it's a very hot topic in academia and industry, and one good applications are very powerful applications in machine learning. You might have already heard, this is autonomous driving vehicle, right? So it started a decade ago in US by their defense agency called DARPA. They launched these competitions for driving a vehicle without any human support. Okay, so the cars are all equipped with these cameras and sensors, and these camera sensors, they acquire the informations from outside on the environment, and there are some softwares which uses this machine learning and takes the information from the image, applies machine learning, and similar to human being, they take the action. Okay, means whether to stop or to move straight or to go left or right. Okay, so you see this this is a video where these cars are moving, okay, without any driver, and these cars can recognize the street lanes, and they also know if there are some vehicles in front of it, and if it is there, they will stop, and then accordingly it will move. Okay, so nowadays there are lots of companies out there in Western countries uh, which actually runs these autonomous driving vehicles. Okay, so they can move in rural area, urban areas, hill areas. In fact, when it's not required to be there in the daytime, sometimes in the night time also, when there are less illumination, still they can understand the outside, and they can run. So that's a very powerful applications, and we have all heard of it, right? That's there are several companies like Tesla, they actually uses these kinds of autonomous driving vehicles. Okay, so here today the agenda is, first I'm going to discuss this in a very short, that what's machine learning, and then we're going to see um, this scikit-learn, okay, scikit-learn, because if you want to implement this machine learning tools, you need some libraries. You can develop those programs in your through your C programs or Java programs, but it will take a lot of time. Okay, so instead of that, you may use some of the tools available in the market, and many of them are actually freely available. So one of them is scikit-learn, which uses Python programming, Python coding. Okay, so Python is very useful, and it is now being used everywhere. Okay, so now people are using instead of this Java or MATLAB, people are using this Python coding. So all this programming of machine learning, data science, this are shifted to this Python environment. So the scikit-learn, they use this Python programming for developing this machine learning. So we are going to see that what is scikit-learn and what are the different components of the scikit-learn, and then a little cheat sheet, okay, of the scikit-learn, what you can expect, how actually you can use this scikit-learn. Okay, in a single figure image, you will understand that, okay, what you have to do. And then we'll do some practicing with this tool. Okay, so how we can load some data sets, and we can run some machine learning algorithms with this code. So this is the agenda of today's lecture. So as I was saying, this machine learning is one of the buzzwords these days, and everyone is actually talking about this machine learning. So if we want to know this the history, so it started in long back, and then one of the first applications, okay, of this machine learning is optical character recognitions. You might heard of it, this OCR. Okay, so and some of this and made in I think many Play Stores or Android Play Stores, you might see these kinds of softwares which you may download and you can apply. So it's like optical character recognition. It's a software, or you take any image, okay, so you take a photo, and then if you apply that software, then those text information in that image will be translated, or will be converted into this ASCII text. Okay, so what these computers could not read, it was only in a pixel level in image. Now this converts to text level, text character level, so that computer can understand what is written in that image. You might have also seen these applications like spam or not spam filtering, okay, in this in different email servers. Okay, so whatever email sites you are working, so there are also several filters like to use this spam. Okay, so what you do is that some mails are coming, okay, in the inbox, and then sometimes you tag them whether it's a spam or not, and then this email softwares, they learn those emails with these tags that okay, this is a spam, this is not spam, and then accordingly in the future mails, if similar mails come, they will say that okay, this is a spam mails. Okay, so these are some email applications you might have already used. Okay, and nowadays there are many more applications are there in our day-to-day life. Some of them are, for example, recommendation systems. For example, if you see, you might have used this Netflix, or in this social media websites, where if you want to buy some products, or you are exploring some products, and immediately there are some recommendations that whether you want to buy these products or not. Okay, so these kinds of recommendations are also a part of this machine learning applications. Similarly, you might have also seen this like Alexa or Google Assistant, which works like an assistant. Okay, so like you can command anything to this kind of tool, and then um, they will learn what you have asked, and then they will search in the net and then find out that what's the answer, and maybe they can communicate to you. Okay, so you may ask that okay, what is the weather today, and then it will find out the weather from internet, and it will tell you, okay, like a human speech, that what's the weather. So you might have already used these kinds of softwares, and many more are available in different sectors, like it can be healthcare, medical image analysis, or signal processing. You can also see these kinds of application in defense sectors, in education sectors, in finance sectors. Okay, so machine learning is there now in different sectors, okay, in our society. Okay, so now so this, if you want to apply this machine learning, you need to do a lot of coding. Okay, so instead of that, so there are actually many libraries out there in the market which helps you to develop this programs, and just you have to make a single line of code, and then you can get the things done. So for example, if you go to market, fish market, and you want to know that whether the fish is for example salmon or sea bass, so you just take a photo with your Android mobile, and then the software will tell you that whether it's a salmon or sea bass. So this kind of simple classification that you can actually easily implement, okay, with this with a just a 10 line of codes. Okay, so you do not need to implement anything. So these can be done using this, for example, MATLAB, scikit-learns, R. Okay, there are different libraries out there. People, we used to develop those programs using C, C++, or OpenCV. Then MATLAB came. Now people are all using Python, okay, for this machine learning tools, machine learning coding. So in Python there are many libraries are available. So one of them is scikit-learn. Okay, scikit-learn is very popular, and it's very useful for this machine learning. So if some of you are novice, okay, and you are just new to this machine learning domain, so I will suggest that you start using the scikit-learn. Okay, so that actually it's very user friendly, and there are lots of instructions, and and many codes are available, okay, in net. Okay, so you can just search, and then you can get them. So it is based on this SciPy and NumPy, and NumPy is basically for to ease to calculate this arithmetic calculation faster. Okay, so if you want to do a very complex calculation, so this NumPy is this is also a library which actually does the calculation very fast way. So the SciPy and NumPy, these are used for this sklearn. So this is an open source, so you do not need to do any payment. Okay, this is commercially usable. Okay, and you may also use for any commercial purpose also. This by the scikit-learns. Latest release is in December 2021. The version is 1.0.2. So what are the components of this scikit-learns? Okay, so in machine learning, you have mainly these 4 different components. First, you know this supervised learning and unsupervised learning. Supervised learning, you have this classification and regression. This can be done using this scikit-learn. In unsupervised learning, you have regressions and dimension reduction. This can also be done using this scikit-learn. So all these functions, all this are there, okay, in this scikit-learn with this simple tools. Okay, just call 1 or 2 functions, and then you can use them in your code. So it has simple and efficient tools for predictive data analysis like classification. So for example, that I was saying that it's a spam or not spam. If you want to go for classifications like it's what type of fish it is, or what kind of fruit it is. Okay, so these kinds of simple image processing. Okay, so this you can use, and there are almost all the algorithms are developed here. So if you want to go for this support vector machines, decision tree, logistic regressions, random forest, these kinds of all these classification algorithms are there. If you want to go for regressions, regression like this is continuous data, that also you can use this. Okay, using this scikit-learn. So you are here you have this linear regressions, non-linear regressions are there as well. So you can use this for the decision tree based approach also. There are different kinds of approaches, algorithms are there for this regression algorithm. Means if you want to predict the temperature of tomorrow, okay, so that's actually regression, so which comes with this continuous output. Okay, that output is in continuous domain. If the output is in a discrete domain and which are predefined classes, these are classifications. So these functions are all available. You can also use this for clustering, dimensionality reductions when the data are unsupervised, means the data comes without any labels. Then you can go for grouping or clustering or like similarly, for example, like recommendation systems. Okay, this is also a type of grouping. So, and this in the clustering also, you have this k-means clustering algorithms and many others. And then you have dimension reductions algorithms. Dimension reductions, you have PCA, LDA, and different algorithms are there, which actually you can use for dimension. For example, you have a dimension, you have applications where you extract 1000 features or a huge number of features, and you want to reduce it to a 4 or 5 number of features. So what you have to do, either you have to select some of the features, or you have to reduce the dimensions. Okay, so either you go for feature selection or feature reductions. So these kinds of approaches are all available in this scikit-learns. You may also go for this pre-processings or for feature scaling, or for example, if you want to go for validations or performance evaluations, like you want to find the accuracy, okay, of this classifications or these regressions. So that those are also available. And then you may, if you are if you like, then you can also go for more detailed analysis of those classifiers, like you want to go for confusion matrix, ROC curves, or for example, if you want to go for a one versus all or one versus rest, different types of this performance measure analysis you can actually do with this in this validations and pre-processings. And another important aspect of this scikit-learn tool is that there are actually data sets, numerous data sets are available. Okay, so which you can use them uh, for your codes. Okay, so for example, you have developed a machine learning algorithm. It is for example, it's a classifier. So you can use data sets like IDs data sets, or you can use, for example, breast cancer data sets or wine data sets. These data sets are for classifiers, okay, classification. So these data sets are all available, and then you do not need to do anything. You just call a single line code, and these data sets will be there in your hand. And then you write a functions for classifications, and it will go to the classifications. So very simple. So many data sets are available in this scikit-learns, that now we are going to see some of these data sets, okay, that we have said that ID is Boston, California. These data sets we are going to see, okay, when we are going to check this tool. Next, we have the scikit-learn as a cheat sheet. Okay, so you see that when we, if you see in a bird's eye view, okay, so in this using this scikit-learn, what you can do, okay, so you can work for classifications when the data are supervised, and this and these are pretty the labels are predefined. Okay, so you can go for classifications. If the data outcome is in continuous domain and it is also supervised, you can go for regression. So you say that when the you want to go for classifying, okay, and then whether this it's a discrete level or predefined level or not, then you can go for classifiers or regressions. If it is just quantity, for example, you want to predict the level, predict the score of Virat Kohli in the next match. Okay, so that's actually a regression algorithm. So, and then if you want to go in a, if you have this discrete level but the labels are missing, so you can go for clustering. Okay, so like grouping of data, that it is of group A, group B. Okay, so this is also possible if the data are there and the labels are not there. Okay, labels are missing. Okay, so that's actually clustering. If you have the data and then this data are with huge dimension, that I was saying, this 1000 dimension, and you want to reduce the dimension, that's actually dimension reductions. That also you can do using this algorithms. So most of the aspects of this machine learnings are there in this scikit-learn tool, and that's why it is very popular. And most of the machine learning guys, data science guys, they actually use this scikit-learn tool. And then who are using this scikit-learn? Okay, many companies Okay, and in academia also we are using. Okay, so we are using the scikit-learn. So if some students are newcomers, okay, like undergrad, BTech, postgrads, okay, so they are newcomers in the machine learning, they start using this, or in the even this in the industry also people use, for example, JP Morgan, Spotify, India, okay, Hugging Face, Evernote. I think some of them are actually I think these are popular, and you might have already visited this companies. Okay, so these companies, they use this scikit-learn uh, for their machine learning parts. Okay, so if you want to go into details, okay, so you have this website. I'm going to explore this website now, but if you are interested, you can also study this scikit-learn papers on machine learning in Python, API design for machine learning software, like experiences from the scikit-learn projects. You may have different books also available, so you can follow these books, okay, for this to know more about this scikit-learn. Now let us see this different um, first this scikit-learn. Okay, so this is the first page. If you join this scikit-learn, okay, so you have this you see that it's getting started, and you just call, okay, this is a library. You call this random classifier if you want to apply it. Okay, so these are already implemented, and these are available in some libraries. Okay, some header libraries. For example, in C you might have used this math.h, some header files. Similarly, these are also some header files you have to call, and then after that, once you have this data sets, you just use these functions. Okay, random forest classifier. Okay, and that's you given the data. So for example, you have this data. X is the training the data with the input attributes, and Y is the levels, and you use this classifier CLF as the random forest classifier. Okay, this is the object. Okay, so what kind of classifier it will use? CLF is the classifier which uses random forest, and it uses this data. Okay, CLF.fit xy. Xy means X is the training data attributes, and Y features, and Y is the levels. So the random forest classifier will be learned with this X and Y data. And that's it. With these 4 lines of code, you actually train a random forest classifier with your data. Similarly, you can use the support vector machines, decision trees, all these classifiers with this 3 or 4 lines of codes. Okay, and if you want to go for this more on this pre-processing and then validations, all these are actually available. Okay, so you have to just explore. Okay, and then when I was talking about the data sets, so first let's see these data sets. You have this is a this in the scikit-learn, this you have this data sets. Okay, toy data sets. You see in this page you will find out many data sets are available. Okay, so let me explore these data sets. These are very interesting because if you develop some algorithms, then you might want to test your algorithm on some data set. And you know that data set is not easy. You might not get always your data sets, your own data set. So if you want to check the robustness of your algorithm, so how will you test? So you can test using these available data sets, which are in small in size, or you can go for some big data sets, okay, large data sets which are already available. So you can also go for some other data sets like Kaggle. Okay, in Kaggle compilations, you might see several data sets. But just to start with, okay, so you can actually use this toy data sets because it is actually easy to load. Okay, so you do not need to do much. Okay, here. So here you will see these data sets are of classifiers, then regression, and then clustering. All kinds of data sets are available. So you have this first one is Boston house price data sets. So is having, so it says this number of instance is 506 examples are there, 506 data points, and there are 13 attributes. Okay, so 13 attributes are there. 13 attributes. What are the attributes or features? Like it's CRIM or per capita crime rate by town. Okay, in that house, in that Boston. ZN, proportion of residual residential land zoned for lots over 25,000 square feet. Then you have age proportion, then different parameters are there. Okay, so these are different parameters. And finally, the dependent variable. Okay, the target is the median value is the that what will be the price. Okay, so what will be the price of the flat, okay, house. Okay, so if you have if I want to purchase on the house, on flat, then given these attributes, okay, so what will be the price target? So this is actually a regression problem. Okay, so this data set is also available. And then you have the second data set is IRIS plan data set. It is a classifications. So here you have this 150 examples are there, and then for each examples you have 4 features, 4 attributes. Okay, sepal length, sepal width, petal length, petal width. So it's like you have one flower, and in this flower you have this length and width, okay, of the sepal and petal. So these 4 informations are available, and then one needs to classify whether that sample is which class, whether it is, there are 3 kinds of flowers, okay, plants. It is Iris setosa, Iris versicolor, and Iris virginica. So given a sample with these 4 different features, one needs to classify what kind of class it is or what kind of category it is. Okay, so these data sets are also available in, it is called IRIS plan data sets. So you see that this is some of these examples. So for example, sepal length is 4.3, 7.9. Okay, and then if you take one data, so you will have one example, one sample is this one. This is the one sample. Okay, so you have this example will be first attribute x1 4.3, x2 2.0, x3 that is petal length 1.0, x4 petal width that is 0.1. Okay, so these are the data information, okay, features, and then class level will be one of these, either it is Iris setosa, versicolor, or virginica. Then you have also some data sets on diabetes. Okay, so here it says it's 10 baseline variables, age, sex, body mass index. Okay, these kinds of information. These are the independent variable. Okay, these are all numeric data, and this 11th data is a quantitative measure of the disease. Okay, progressions. Okay, so you want if someone wants to know that progression of this diabetes 1 year after the baseline. Okay, so that this can also be used. Okay, these data sets. So you have different individual variables and these dependent variables also. This is a regression analysis. Similarly, you have also a data set of this character recognition. Okay, OCR that I was telling that given an image, so can you predict whether it's 0, 1, or 2? Okay, so there are actually outcome is of 10 levels, 0 to 9, and that image is of 64, that is 8 cross 8 images there. So you will have one image, where you will have this 8 cross 8 pixels. Okay, so that means you will have 8 pixels in row wise, 5, 6, 7, 8, and then in column wise also 8 pixels. Okay, so you will have all this, and total you will have 64 pixels. Each pixels can be of intensity 0 to 8 cross 8 image of integer pixels in the range of 0 to 16. Okay, so it could be actually 0 to 15. So you can see somewhere you can see that whether it is a 0 to 15 or 0 to or 256, because if it is the level is 2 to the power, there are, if the intensity level is of 8 bits, then it will be 2 to the power 8, that is of 256, right? So that you have to check either it is 0 to 15 or 250. So this information, so you have this image, you have an image of 8 cross 8 pixels, and then you have to predict whether it is what is the class 0, 1, 2, or up to 9, which category it is. This is also a classifications. Then you have data sets of linear data sets, then wine recognition data sets. Some of them are actually classifiers, some of them are regression. This is breast cancer data sets, and some of them. Okay. So now you might have understood that in this library you have already they provided this data sets are available. Okay. So now if I want to start, okay, so with this uh, tool, okay, with the scikit-learn, and then how actually we can use. So you have this you start with this import numpy as np. Okay, so that's and then import pandas at pd panda library is used for this matrix calculations. Okay, there are actually data frames are there, and to for this analysis of this matrix frames. Okay, so this tool is actually used because you will be using this images, or for example lots of data with this in a table. Okay, so these kinds of tables, so they are actually this panda this can be used. And then you use starts using this data sets like from sklearn import data sets. So it will download all the data, whatever data sets you want, it will actually can be used. Okay, so you just call this header file. You can use this train test splitting. Okay, so if you want to, if you have a data sets, you if the data set is not divided into training and testing parts, so you can also use some training testing parts. And then if I want to say that I'll go for this logistic regressions or decision tree classifiers, then I will call this these two headers, okay, logistic regressions and decision tree classifiers. And these are for metrics. Okay, so like if I want to go for classification scores, like what is the accuracy, or what is the r square, or for example this, what is the difference mean squared error. Okay, or if I want to check this ROC curve. So this actually you can use this kinds of using this libraries. Okay, so now let us see that how actually I can call this functions. Okay, so if you see that if I just call this, for example, this data sets dot load underscore breast underscore cancer. Okay, so that's what you have. Okay, this breast cancer data sets you have. If you use this data sets, okay, so all these data sets will be so if you see this data sets, you have this load let's see this load, you see these data sets load boost on load breast cancer. Okay, here you see this functions data sets here. Okay. Sorry, I wanted to show you these different data sets available. Okay, so just you call this line and it will actually load these data sets. You have load Boston, load breast cancer, load diabetes, load digits, load iris, load linear. Okay, so all linear, all these data sets can be downloaded. Okay, in the single line. So now you use this data sets, and then from that data sets you have these features in your X, and you have this target in Y. Okay, And now what we want to do, I can split. Okay, so if the data sets is not separated in training and testing, what I will do, I will make this training and testing. So I say that, okay, 70% of the data set is for training. Okay, so let me say that, for example, if I am having a data set which is having 100 samples. Okay, so one sample to up to 100 samples. One samples you have, for example, you will have uh, n number of features, and this is the y. Okay, so x up to xn, and this is the y. So this the feature level, it is x1, x2, x3, and this is the y level prediction. So this is the one sample that we have seen in the iris data set. That is, you have four attributes: sepal length, sepal width, petal length, petal width, and the output is whether it's a setosa or virginic or versicolor. So we will have these attributes, and this is the final level. Okay, so here it is that whether it's a cancer, malign or benign. Okay, this is yes or no, and there are different features, attributes. Okay, and now what we are doing, I want to divide this 100 samples into, means I'm saying that out 70%, let us consider 70%, means 1 to 70. I say that it will be 1 to 70 will be for training, and 71 to 100 will be for testing. Okay, so what I want to do here, so I'll be using this split. I just make this number. That split is, what is the number? Total len x means total number of data you have in the x. Okay, x is the total number of data. How many data are there? So it tells me that 7 in 0.7 into x. Okay, if you have 100 x, then that means 0.7 into x means 70. And then x train and y train equal to x colon split. Okay, so that means it starts from 0. Okay, so as some of you might have knowledge of this Python, so it starts, if you just do not mention anything, that it means 0 colon split, it is the x training. So you have this, if it's 70, split is 70, that means 0 to 70, it will be for training, and 0 to 70 for the y, from the y, it will be also used for training. Testing the remaining data. Okay, so split from 71 to 100, the rest, it will be in the x test, and in the y also, in the predictions, the split colon rest, it is actually in the y test. So you divide the training and testing data. Okay, now if you run this, okay, so first you have to use this. Okay, so you see that here what we are doing, it's actually a Google Colab. Okay, so that you can use this Jupyter notebook also and Google Colab for running these kinds of tools. Okay, these are actually very simple. I think some of you are already aware of this. Okay, so here you can in Google, you just write Colab, and then these kinds of uh, a notebook will appear, and then you can write your code. Okay, so for example, you want to start write one line. Okay, so you just make it a line, and then a single line, whatever you can write, you can do it, write it here. Okay, so this is a Google Colab, and you can also, and these are all, this can be, Google Colab can be done through with internet. Okay, so if you have internet facilities, then you can use it. Otherwise, you can use this Jupyter notebook. Okay, so which you can you have to install this Jupyter notebook, and then you can run those programs. Okay, this scikit-learn you can run through this Jupyter notebook as well. So we have divided the data sets into 70-30. You can make it in a 60-40. So if I just mention it to 0, instead of 0.7, I can make it 60. Then I can actually do it 60 to 40. So if I run this code, okay, this part, simple part, and then you see that it is it will tell you what is the data. Okay, so train shape, testing shape. Okay, so if I training data, okay, it says this training data. Train data is 300 x train shape and y train. Okay, so what is the size? 398 samples, and you have 30 attributes. Okay, if you see this breast cancer, let's see, you have 30 data, right? 30 numeric data and one predictive outcome. This is the class level. So here you have this mm, train data. If I want to print, okay, this x train dot shape and y train dot shape, okay, so that means 398,30, that is the basically training data shape, okay, size 398 samples and 30 features. Here y train is 398 samples and feature is, this is basically one outcome. Okay, and in testing, what is the testing shape? So you have 171, that is basically 30% of this data set. Okay, so you have what is the data set size? If you see the 567, okay, out of 567, if you consider 30%, it comes around 171. And now if I want to go for a classifier, okay, so if I want to, this is a you see this this data set, it's having this classifier, it's a yes or no, malign or benign. Okay, you have two levels, it's malignant or benign. Okay, so that you have to classify. So I can do it using a simple classifiers like logistic classifier. Okay, logistic classifier, it's a binary classifier. So given the data, it will classify either it's a uh, malignant or benign, similar to your spam dataset, spam email. So given an email with some features, it will tell or predict whether the email is spam or not. So here it's this classified logistic regression will also tell that whether it's a malign or benign. So what I want to do, so I will be I have to fit, okay, this data with a logistic regression. So this is a variable which actually runs with this logistic regression dot fit, okay, x10 and y10. So I just provide this training data of this features and labels, and I fit our logistic classified logistic regressions in this data. Okay, this is the single line, and the logistic regression is learned, okay, with this training data. And then if I want to predict, okay, y underscore predict with this is the object. Okay, so I just use this object with this learning model here, and this log logistic regression, this variable dot predict, and then I will find out what is predict in the x test. Okay, so I want to predict this levels of this testing data, so it will predict the results as well. Okay, so if I want to now find out the accuracy, okay, this y underscore predicts, and what is the accuracy? So what I will do, I will just check, I have to compare. So this, if you just see this results of y underscore predict, okay, sorry, okay, so if you just print, so what you see the results are either 1 or 0. Okay, so it's predicting the testing data either with 1 or 0. Okay, that means it's a malign or benign. And then in the testing, you have already the levels which are actual level. These are all predicted levels. Okay, these predictions we have just printed. You can also have the actual level, okay, in the data set. These are all there. So, and then we just compare whether these predictions and the actual, they're correct or not. So that's actually this accuracy. So accuracy score, this function, you do not need to do anything. So that's, we have already called these functions. Okay, if you see this accuracy, you also have this accuracy score, okay, this scikit-learn matrix. So we have called this function, and then we have also this logistic regressions, anything. Okay, so whatever you want to use. And then if I use this, okay, accuracy score, so you have the results accuracy as 92.98 here. Okay, that's the accuracy, right? So that means out of 100 data, 92 data, 93 data are predicted correctly. Okay, so that's the accuracy. So whatever we have predicted with these levels, these are actually prediction. This using this scikit-learn, with this logistic regression, this is actually 93% is correct. If you want to test with this F1 score, I think you all know that what is meant by this F1 score. you have to find out the precision recall, and then from this precision recall you can combine these two metrics, and then you can get the F1 score. F1 score is 2 into P precision into recall by, in the denominator, precision by plus recall. Okay, it's a harmonic mean of this precision and recall. So you can also find out this precision, this F1 score. So if you can just write this classification report, and that's it. Classification report will show everything. Okay, so this classification report will tell you what are the results. Okay, this precision, say for example, for 0th class, what is the precision recall F1 score, and then you have this precision recall and F1 score. Okay, so you have for support means 39 data are there for 0 level, 32 data are for 1 level. Okay, so these are the support means. And then you have this accuracy. So when we calculate this precision recall and this macro average and weighted average, so these are basically, it multiplies with this support. So 39 into this precision plus 132 into this 0.99. If you divide by this 132, it will become this 94.24. So okay, this is the weighted average. Okay, this is the weighted. And macro average is, if you just divide it, this plus 2, if you just add this 0.99 plus 0.77 by 2, it will become this simple average. Okay, from this two. This is for category 0, and this is for category 1. Okay, and then if I want to make an average of these two, so this is the macro average. Okay, so this is the macro average. And if you want to get go for this weighted average, where you want to combine with the number of samples, then you can go for this weighted average. Okay, so this is the classification report. You can also go for this true positive rate, false positive rate, confusion matrix, all this. Okay, so you can use this confusion matrix. So if I just try, so here if you go for this confusion matrix, the simple functions like confusion matrix. Okay, so with this confusion matrix, it will actually tells you that what is the true positive, true negative, false positive, false negative, all the details. So if you find out this in this, okay, so you have this malign and benign, and you have this true levels, malign and benign, and this you can also get this kind of confusion matrix. Okay, where actually this you can make sure that, okay, what is the true positive, true negative. Okay, so this can be also shown using a single command. Okay, this print confusion matrix. That's it. With this, yeah, you have a print confusion matrix is the header, and then you may use this print CM. Okay, this confusion matrix is the function. If you use this CM here, that's actually, it will print the confusion matrix details, right? Confusion matrix details is this one. Okay, so you have this confusion matrix 38, 1, 11, and 121. And if you want to use, if you want to find out this true positive rate, false positive rates, all this, you can write a simple functions, okay, using this Python, and then you can get the details. Okay, so here in this using this logistic regression, you have this true positive rate as 91.6, and then true negative rate as 97.4. And now if I want to go for this, for example, this decision, if I want to go for using this ROC curve, okay, so ROC curve also I can try, and there you require this true positive rate and false positive rate. If you know this ROC curve, so where this two metrics are required, okay, so you can also calculate this false positive rate by true positive rate. Okay, this is just a random number, and according to your accuracy, this ROC curve area under this ROC curve will actually depend. Okay, so this you can find out using this simple curve. Okay, ROC underscore UC is actually AUC, area under curve. Okay, and it actually takes two parameters, false positive rate and true positive rate. Okay, so if you use that, you'll get the area under curve. So area under curve you can calculate. Okay, so here it is mentioned area under curve as area equal to 1.0. okay, Okay, so should not be like this. Okay, so yeah, you have this, and then I think it's you can start playing with this some data sets and this classification. Now you can also use some other data sets, so like a low IRIS data sets here. Okay, so IRIS data sets also you can use, and the same thing. Okay, so it's a logistic regressions, predictions. Okay, using simple functions, and you can call these data sets on this and then apply this your logistic regressions. You get the accuracy. You can find out the confusion matrix. Okay. You have now this okay, so you have this. For example, if I want to compare two different classifiers, okay, like if I want to compare with this decision tree and logistic together, okay, so I want to compare with this breast cancer data sets, and these are the divisions of this training and testing. So I have taken a random shuffling. Okay, so random shuffling with 70% training and 30% testing, and then I am using this logistic regressions fitting with this data sets, and then I am also using decision tree, okay, in this data sets, and these are the predictions. Okay, so using this logistic regression, what is the results? Y underscore prediction underscore probability LR. Okay. So this is the probability. If I want to find out, just it will give you the accuracy. Y underscore predictions underscore LR. Okay, this is the prediction on the X testing data sets, and these functions will give you the accuracy on the testing data. If you want to know that, okay, so given a sample, what is the probability that whether what is the score, okay, or the confidence of that classifier. So for example, if I'm having a logistic regression and it given a new data, it says that it is a malignant or benign, it's 1 or 0. But you can also say that, okay, give me your confidence that it is 70%. You are saying that it is a malignant, or you are saying 90% confident. So this actually you can do it using this LR, this variable dot predict underscore probability. Okay, so this will give you the score. Okay, so probability of what is the confidence of the classifiers to predict that sample. So if I want to plot, okay, so here you have we plot using this ROC curve. Okay, so ROC curve, you have this decision tree and linear logistic regressions, and here you see that which classifiers will be good. How will you say? Basically, you can check with the area under curve. Okay, so area under curve for decision tree is showing 95, 0.95, whereas in logistic regression it says 0.99. That means here this logistic regression actually is better than this decision tree, because it covers more area than this logistic simple decision tree. So using this visualizations also, you can actually understand which classifier is better. Yeah, so more or less I have shown you what are available. Okay, so and there are many more things. Okay, so you can go for this regression, linear regressions. You have polynomial regressions. Okay, so I can show you this scikit-learn. You have this you have this linear regressions, so you can fit a line fitting. Okay, so you can use a line fitting here. So just want to see this, yeah, linear regressions here. So this can be done using a simple line as well. Okay, so you have this regressions using this linear underscore model dot linear regressions, and you use this regression dot fit. That's it. And then after that you do the predictions. Okay, so with this simple 2-line code, you actually train a model and also you do predictions. Okay, so how simple it is, this tool. Okay, so that's actually, this is designed to make it very comfortable. Okay, for any kind of users. So this will help to have a quick start, okay, with this machine learning. So that's how actually this scikit-learn is designed. So with this simple two-line code, you can predict the data. Okay, so whether what will be the class level or it will be the for example score of Virat Kohli's run, okay, in the next match, or what will be the weather forecast. Okay, so thank you. So I think I have completed what actually I intended to talk. So to summarize what we have discussed, first we have seen this what is machine learning, what are there in the machine learning, what actually you see. So in the machine learning, we have seen one examples with this autonomous driving vehicles, and then we have seen also several day life examples, applications of this machine learning where these machine learnings are applied. Next, we have discussed about this scikit-learn. Okay, so what are the different components in this scikit-learns, and then how uh, how mm, how you can use it. Okay, so what are the requirements? So there are mostly these 4 different blocks: classifiers, regression, dimension reductions, and clustering. Okay, so 4 different blocks are there. So when you want to use which algorithm, and then we have also discussed there are several financial companies or industrial industries which actually use the scikit-learns. And second half, we have discussed this code. Okay, so how you can load some data sets from scikit-learn which are already available. You don't need to do anything, just a single line of code. It will load the data set. You can also load some your data set as well. Okay, so if you have some data in your Excel file or .csv file, this also can be downloaded with a single line, okay, functions. And then once you have the CSV files or this data, you just divide into training and testing, and then you feed your model in the training data and predict from the testing data and see that what is the accuracy. For predictions or for validation, visualization, there are different metrics like, for example, cross validations or ROC curve, confusion matrix. All these are actually available in this scikit-learn. Yeah, thank you. I think, yes. So if you have any questions or doubts, you please ask me.
Thank you. Thank you very much, sir. That's wonderful. And your talk was definitely wonderful. It is absolutely aligned with the theme of the FDP, data science and data modeling tool we were expecting. And this is the positive perspective of the COVID, that the professor like Partha, we can directly request him and can tell him to come on live for interaction. Otherwise, physically, it's not possible because of your, you are busy in so many things you're doing, the research projects and collaboration. This is the positive impact that you are here and you are sharing your valuable information in the area of research to all of us, to all young aspirants who are in the area of the machine learning. And definitely, I'm also thankful to my head of the department, Dr. Jatinder Manasji, whom I requested he kindly see if Partha sir can come over. So he ranked you and you said, okay, I will go ahead. That's really thank you. Thank you very much, sir. And no, Jatinder Manasji sir is there. I think he will speak few words for you, sir.
Yeah, thank you. Thank you very much. Thank
Good afternoon,
you.
sir. Good afternoon.
Yeah, good afternoon, sir. Yes.
Let me add one thing that although Professor Partha remain busy in his assignments, but whenever he is requested from the Bhadrava campus to share his any valuable experience, he's always ready for us. So this is his greatness that he's never say no to us. So anyways, a nice talk.
Thank you very
Hopefully
much.
all these scholars, faculty member has learned so many things from you. So anyway, sir, thank you very much. I have a number of times I have privileged to learn from you so many things. So
thank you very much. Thank you very much for inviting me and allowing me to share my knowledge with all the students and the faculties.
In near future also will continue with the same. And thank you, sir. Thank you very much.
Thank you very much. Thank you. Okay. Thank you.
I also once again thank you, extend my very warm thanks to you, sir, on behalf of Department of Computer Science, Badava Campus, University of Jammu, as well as my counterpart, Teaching Learning Center of Ramanujan College of Tally University, Dr. Arun is also there. So we are really very happy, sir. We are very happy. Yesterday, I think day before yesterday, I just rang you, head of department has rang you, and you have given your valuable time. You said you will be ready for the talk, and your talk is really aligned with the theme. That's really the beauty which I will appreciate, sir. And definitely in future we will also keep in touch with you and learn a lot of things from your side as well, sir. Thank you once again. And Dr. Arun, would you
Thank you
like
very
to
much.
add something? Dr. Arun from Tari University, please go ahead, sir. I think he's so fine, sir. We have the beauty of this FTP is this is also live streamed on YouTube, as well as we have already launched a self-paced course on the YouTube parallelly. And if certain queries are there, definitely we will reach to you through email and through other means, and get your support in that sense, sir. Thank you once again. On behalf of all, I thank you, sir. Thank you
very much. Thank you. Okay, nice talking to you. Bye.